In this video, we will look at systems of equations and determine how many solutions they have. In order to do this, we really just need to begin solving it, and then we will get somewhere. We will either get an answer, or we will get something that doesn't look true, so it has no solution, or maybe we end up with something that has infinitely many solutions. So let's begin by solving. This first one can be solved in a few different ways. You can go about it by using addition, but I immediately see that we have this x that is all by itself, and so really it would be pretty simple to isolate it by subtracting 3y from both sides. So I end up with x equals 3 minus 3y. So I'm using substitution. So I can now take this expression that I created for x and I can plug it in for x in the other equation. So I get 2 times 3 minus 3y plus 6y equals 5. Now I am going to continue solving for y, and I get 6 minus 6y plus 6y equals 5. And then immediately we see kind of something strange happen with this minus 6y and plus 6y, and we get 6 equals 5, which 6 does not equal 5, so this is not true. And when we end up with something that's not true, we know that that means there's no solution to the system. Let's try another one. How many solutions does this system have? Similar to above, we just need to start solving it and see where we get. Now, when I see something like this, right, I see a lot of numbers, they're kind of maybe bigger, everything is lined up really perfectly. We have our x's, we have our y's, we have our constants. This to me looks like a perfect candidate for addition. Now, it's not quite ready because we need to do some multiplication. So I see that to make these two guys cancel out, this needs to be a positive 15. So how do I make that a positive 15? Well, I multiply everything by negative 3. So I'm going to encourage you to pause the video, finish this problem, and see what you get for your answer, and play the video when you're ready to see your solution. So here's what I ended up when I solved the problem. It's great that we had something cancel out, but actually both of our variables canceled out. And when that happens, we actually don't have anything to solve. So we end up with 0 equals negative 3, which is not true. So there's no solution. Let's try another one. How many solutions does this system have? Okay, just like the others, we're going to approach it by just starting to solve it. So you may look at this and try to figure out what is the best way to solve, thinking about substitution and thinking about addition. Well, I kind of see that this is actually perfect because it's already ready to be added together. We have a negative 8 and an 8 in those x's, the y's are ready, and then the constants are ready. So let's start by adding. So those cancel out. We get negative 6y equal to negative 12. So then I solve for y, and I get positive 2. And then I'm going to take this value for y that I got, and I'm going to plug it back into an equation. So I get negative 8 equals, negative 8 times x minus 3 times 2 equals negative 14. Now I'm going to figure out what is x. Negative 8x minus 6 equals negative 14. And then we add over our 6, and we get negative 8x equals negative 8. Oops. And so x is actually equal to just 1. Now, I didn't maybe really have to finish solving the whole thing out, because really my whole question is how many solutions? This is just one solution. We ended up with one final solution. Let's try one final example. This says find the general solution to the following system of equations. This is a little bit different. It tells us to find the general solution. So that actually implies that there are infinitely many solutions. How do we know when we get something that has infinitely many? What does it look like? Well, let's see. Let's say we had no idea what was coming and we just were told solve this system. Maybe you got this problem on an exam. Okay, let's solve it. It looks like it maybe would be ready for addition if I was to do a little bit of work to it. So let's try that. Or you may think, why would she do that if this was ready to be isolated? So we could do substitution also. Either way, we're going to do substitution or addition. And since I actually prefer substitution, I didn't realize that was like that. Let's go ahead and just isolate for x. So we're going to subtract 2y and we get 3 minus 2y. So now we just get to put this right in there for x. So we get 2 times 3 minus 2y plus 4y equals 6. Okay, distribute. 6 minus 4y plus 4y equals 6. 6 equals 6. This is true. This is how you know there are infinitely many solutions, is when you get a true statement. Now don't stop there. We need to find the general solution. So if we can plug in any number, any x value, and this will become true, what then do we get out for y? So that means we actually just need to solve for y. So we're going to write some general coordinate point. So let's say we start with that first equation. Really, remember, you can do this for either, but the first one looks like it's a little bit nicer to deal with. And let's solve for y. So we get 2y is equal to 3 minus x. Remember, we're trying to isolate, this y value right here. And then the last thing we need to do is divide by 2. So we get that y is equal to 3/2 minus 1/2 x. So that's what our y value will be in this general solution. So what that means is that anytime we plug in some x, remember we get to plug in any x because it's a general solution and there's infinitely many. Any x will work. What comes out as y? Well, every single time, this is going to come out for y. Negative 1/2 times your x value plus 3/2. And that's your general solution. Remember, it's any real number. We won't worry about that. So infinitely many, and then we get out y. So this is actually the y value. And that's how we get a general solution.